Motorboat question. We're given a situation where we have a motorboat that's traveling eastwards at 16.0 meters per second, and we're asked if the river is 1.36 kilometers wide, how long does it take for the motorboat to reach the other side? Well, the first step is to analyze the question, see what's going on here. Um, and you'll notice that the boat is traveling eastwards at 16.0 meters per second, but there is a water current that's pushing at 1.50 meters per second north. And so you'll notice that it is taking this northeasterly approach, this northeasterly approach going this way. And from our previous question earlier, we actually did the trigonometry functions and all that stuff. We also did Pythagorean theorem, and this is what we got as our velocity: 16.1 meters per second, 5.4 degrees north of east. Now our next question is asking how long does it take to go from shore to shore. So if it started here and it ended here, which is like from there to there, how long did it take? And so the first step is to figure out what we're given and what we don't know. We know the width of the river, or you can also say the distance of the river, which is 1.36 kilometers. Now note that this is not the right units. And the reason why is because if you look at the velocities are both measured as meters per second. Meters in particular, you'll notice that it's actually using the base unit and not a prefix. And so we got to make sure that our distance, our width of the river is in the right unit. So we're going to have to convert kilometers into meters. And so to do that, what we're going to do is we're going to start with what we're given, 1.36 kilometers, and we'll multiply it by our conversion factor. Our conversion factor is going to go from kilometers to meters. And so I'm going to put my kilometers on the bottom, my meters on the top, so that way my kilometers will cancel out. And every 1 kilometer is worth 1,000 meters. So you're basically taking 1.36 kilometers and you're multiplying it by 1,000. And at the end, you should get something like this: 1,360 meters. And so this right here is the distance of the river from point A to point B. And so I'm going to write that down here. The 16.0 meters per second is my velocity going in that direction, and my distance in that direction as well is 1,360 meters. Well, now that you have your velocity and distance, you can actually solve for your time, which is what our question is asking for, mainly by using this equation here. Velocity equals distance over time. Time is your unknown value, so that's your unknown value. However, he's in the denominator, and in order for him to be solvable, we have to make sure that he's a whole number, not a fraction. So he has to be in the numerator, plus he has to be isolated. So we need to rearrange the equation algebraically in order to solve our answer. And so the first thing I'm going to do is I'm going to take the time and multiply it on both sides, so that way the time will be in the numerator. So now we get this: times multiplied by velocity equals distance. Now that it's in the numerator, we have to make sure that's isolated, so we got to move the v to the other side. And so to do that, I got to divide v on both sides. So that will cancel out. And our new equation is times equals distance over velocity. Actually, all I did was just flip the velocity and the time on the other side. Anytime you have an unknown in the denominator, all you have to do is just flip him with the other variable on the other side of the equation. And that's how you get this. Alright, so now our equation is set up. All we have to do is go ahead and solve it. So times equals distance over velocity. So my distance, again, is 1,360 meters. We're going to divide that by our velocity, which is 16.0 meters per second. And then we're just going to go ahead and solve it really quick. And our answer is 85 seconds. And so that's how long it took the boat to reach from one shore to the other shore.